CrossFit or Hyrox involve functional movements performed at high intensity. You're constantly hitting intensity zone 4 or 5. So is there a place for low intensity, high volume training as defined by zone 2? Can it improve your overall performance? In this video, I will break down what exactly zone 2 training is. And I will show you several methods ranging from very simple to more advanced to determine your individual zone 2. I will explain how both volume and intensity have a different effect on your mitochondria and how you can use that information to know whether you as a high intensity athlete needs zone 2 or not. This video is a bit of a longer one because I really want to dig into the science of zone 2 training. I hope you're ready for it. Let's go. Hi everyone, I'm Gomar. I'm a senior scientist at ETH Zurich based in Switzerland. And for the last decade or so, I studied the interaction between nutrients and exercise and how those affect muscle growth. I've been fascinated by exercise physiology my whole life, and now I want to bring some of those concepts to high-intensity sports such as CrossFit, Hyrox, but also other varieties. I'm sure you've heard about Zone 2. Zone 2 is all over the place. You have to do it to increase your performance, otherwise you are missing out. Could be true, and in this video we will first define what Zone 2 actually is, because that's obviously very important, how to define Zone 2 for your individual level, and then how to use those concepts to actually improve your high-intensity sport, and if they can actually improve your high-intensity sports. So Zone 2 training is characterized by the threshold where there is a first significant increase in anaerobic energy production. So anaerobic means without the use of oxygen. So that's very important to know. So everything before that threshold, that point, would be basically aerobic training where 90 to 95% of your energy production to propel the muscles is actually aerobic. So the question now is, how do we define this threshold where there is this first bump in anaerobic energy production? And there's several methods or several ways, going from very simple, non-scientific, to more scientific, more detailed, more difficult to do because you need some kind of equipment and also a lab. The simplest way that I found and that I think is also usable for many athletes would be Zone 2 is the pace at which you can still talk to your partner, to your training partner, while you are running, rowing or biking. I hear you thinking already, Gomar, this is a scientific channel. Like, what are you even saying? This is not very scientific way of determining your Zone 2, the pace at which you can talk. But let me dig into it. It actually has some scientific basis. Why? Because if you can still talk to your partner, this means that your breathing frequency is on the lower side. And breathing frequency is linearly, at least in the beginning, is linearly related to your training intensity. It goes up linearly with intensity, but then at a certain point you maybe felt that yourself, it's getting harder and harder to talk, or it's getting harder and harder to even breathe, right? And at the end of exercise, you're breathing really hard like a horse. There is a reason for that, because aerobic metabolism obviously produces CO2, consumes O2, but when the anaerobic metabolism kicks in, there is an excessive production of lactate, because that's a byproduct of anaerobic metabolism, but also H+ protons. And these H+ protons, they acidify the blood. And that's bad, the body doesn't want that, it goes out of homeostasis, so it will be buffered by a chemical reaction which involved bicarbonate. And that chemical reaction produces CO2 more than before, than at lower intensities. So that excessive CO2 obviously has to go somewhere, and that will be bred out by your increased breathing frequency. So the ventilatory threshold 1 would be the first bump, as you can see here on the graph, in breathing frequency, and that would be, let's say, the end part or the end zone of your Zone 2. So that's a good way of defining your Zone 2, I would say. Then we get to another way of defining Zone 2. So I went to Instagram. If you don't follow us yet, do that now. I do try to interact with the community quite a lot there. And I asked them, if you are doing CrossFit or any high intensity sport, do you also incorporate Zone 2 in your training? And a high percent actually said yes. And then I asked, how do you define your Zone 2? And most of the people said via heart rate. So I had to incorporate it here. I would say it's a pretty simple to medium way of defining your zone 2, but the accuracy is pretty medium. I will explain that now. Many big brands such as Garmin and Polar, but also scientific research indicates it should be around 60 to 70% of your maximal heart rate. But here there's a problem, because many people don't really know their maximal heart rate. They say, yeah, whatever, when I did a hard run, I once saw 195, I think that's my maximal heart rate. Or they do it based on some kind of a formula, for example, 220 minus the age, or 270 minus 0.7 times the 8, whatever way of doing it. It will always be based on bigger populations and probably not accurate for you individually. And if you don't have the accurate maximal heart rate, obviously the 60 to 70% will also not be fully accurate. It's a way of doing it, but I think it's not the best way. A more accurate way, and also pretty simple, would be defining your zone 2 based on your functional threshold power. We at wod-science program also training programs. One of them is a 12-week program where we try to improve your functional threshold power, so your aerobic capacity. If you want to look a little bit more into that and join our programming, just click the first link in the description. So what do we do, and what is also working for us according to our experience, is we first define the functional threshold power. What is that? Very simple. You put yourself on an erg, a bike, a rower, or even a ski, and you do a 20-minute all-out test where you average the power throughout those 20 minutes. So basically it's the amount of watts you can produce throughout those 20 minutes. Obviously you need to pace it, and also you have to, I would say, tape the screen so you don't know at which pace you're going, only the time that is still left. But that is a very good way to know approximately your threshold, because if you take 95% of that value, you have your functional threshold power, also defined by many research studies, and that would be, let's say, your ventilatory threshold 2 or close to your anaerobic threshold. Not so important for this video. More important is how you can use that number for defining your zone 2, right? Your aerobic training zone. And this would be 65 to 70% of your FTP. This will be a good method of defining your zone 2 via FTP testing. Then we have to go to the, let's say, the gold standard in research and also in athletic development. That would be via lactate. I touched upon it before already in the beginning of this video, but lactate is a byproduct of anaerobic glycolysis. So glucose, sugars, are first broken down via the glycolysis, we call this glycolysis, into pyruvate. And then the body has to decide if there is sufficient amount of oxygen, it will be shipped towards this pyruvate, towards the mitochondria. We'll talk about that later. And if there's not sufficient or there's insufficient amount of oxygen, this pyruvate will be broken down into lactate and H+ ions, as I touched upon before, and that will also generate some ATP, some energy. So the main byproduct of anaerobic metabolism will be lactate, and we can obviously measure this in the earlobe or with a finger prick quite easily. So what do we do to define very accurately in the lab, for example in elite cyclists or good athletes? We measure their lactates during an exercise test to exhaustion. And what is important here, if you ever want to do such a test, that you have to ask that the intervals at which the intensity increases are long, 5 to 8 minutes. So what I did a lot in my PhD, and when I was testing elite cyclists, I'm talking about the best of the world, we did 8-minute intervals. So you start at a very low pace, and you can see here the lactate obviously in the beginning stays very low, because the aerobic metabolism is basically producing most of the energy, and if there is some lactate production, it also gets consumed by the type 1 fibers. Not so important here. But then here you see at 25 minutes there's a first increase within the block. So you take 2 times lactate after 4 minutes and after 8 minutes. Within the block there is a first increase in lactate, and this lactate increase would be arbitrarily put at 0.5 millimolars per liter, and that would be the interval or the block where your zone 2 training actually ends. So that's a very accurate way of defining your zone 2 or the end part of your zone 2. And then obviously if you have this whole lactate curve, at the end it goes exponentially up because the aerobic metabolism is insufficient to provide enough energy at higher intensity, so the anaerobic metabolism have to kick in, and there's high lactate production, as you can see at the end side of the curve. So this would be your zone 4 and even your zone 5 training, and also your threshold power. This is a very good way of defining all your zones. So your recovery zone, let's say zone 1, then zone 2, as I just said, the first increase in lactate, and then zone 3, 4, and then also zone 5, which is really in this high lactate producing zone, typical CrossFit style, I would say. So that's obviously interesting, but most of you won't do such a lactate test. It's also quite costly and maybe a little bit over the top. And then we also have to talk about NURSE. I talked a lot about NURSE in my previous videos. I will link a couple of them also in the description and popping up right now if you want to learn more about NURSE. NURSE is simply a measurement of the amount of oxygen within a focal point in your muscle. So I'm now pointing at my forearm, but you can also do this at the thigh during exercise. So you can live view how much oxygen there is within a tissue. And obviously when you start exercising, you can see it here. This is an exercise test of an elite CrossFit athlete. And she started at a very low pace and always on the bike, harder, until at the end she couldn't handle it anymore. And because the muscle always uses more and more oxygen, this oxygen goes down. And again, we want to know at which points the muscle kind of breaks. We call this the break points, right? Comparable to your ventilatory threshold 1 and 2. And you can, in this case, you can beautifully see that initially it goes linearly down, but then it starts to go down more. And this point would again be the end part of your zone 2, threshold. And then you even have a second, let's say, threshold or a NURSE threshold, you can call them like that, more at the end, where this would be related to your ventilatory threshold 2 or your threshold power, FTP power, but not shown here on this graph. So I think that's quite an easy way, because now also, for example, this is based on Train Red data, so that's a supplier of this device. They can actually already automatically assess these thresholds based on a test. So you just strap on the NURSE device and then automatically you get your thresholds. Is it perfect? I mean, it's an interesting question. Some people say, yeah, it's not 100% correlated to measuring thresholds via lactate. I always argue maybe not, but lactate is a more systemic way of measuring your thresholds. It pulls all the lactate that is coming from all the tissues in the blood, and then you measure lactate. It's a systemic way. But here, you're really looking at the threshold individually within a muscle. So it could be that your thresholds during rowing, right? Anaerobic, aerobic threshold, whatever threshold you look at, is different in the thigh compared to the biceps. Okay, and this you cannot see with lactate. So that's why I think if you strap on 2 NURSE devices, you actually have much more interesting information compared to only measuring lactate. Good. That's just my 2 cents. So that's cool. We have now different ways, from more advanced to very simple, on how to define your individual zone 2 threshold. Before we go into how we can use that information to know if you actually need zone 2 training, because obviously that's something else, please let me quickly ask you to like this video, and also, if you want, provide some comments on how you see your individual training related to zone 2. It really helps out the channel and only takes 1 or 2 seconds of your time. Thank you for that. Good. So now the question, right? Does CrossFit actually need zone 2? And before we can go into that, we have to talk about the mitochondria, because it's key to understand this. So mitochondria, we call them the powerhouses of the cell. Why? Because they can produce ATP or energy to propel the muscles via aerobic sources. So everything that happens in the mitochondria is aerobic. Important to understand, with oxygen. And they, let's say, convert chemical energy, fats or free fatty acids, and also sugars, glucose, into ATP that we can use then as mechanical energy with the use of oxygen. And in CrossFit, it's always, within programming, it's always a question, right? Volume versus intensity. And what is cool, I found a super interesting paper. If you're interested in this topic, I would highly recommend you to read the full text of this paper. I will link it again, like always, in the description. And here they try to understand if volume or intensity differently affects mitochondria, the amount of mitochondria and how well they work. So what did they do? They pulled all the studies that looked at literally with an electron microscope, so with a very detailed microscope, they could actually measure the amount of mitochondria that are within each muscle fiber. So you can literally count the number of mitochondria within a volume of muscle fiber. And then they did different types of training and measured this before and after in a muscle biopsy. So that's very cool, let's say, detailed research in exercise physiology. And what they found here, I think very important, is that the mitochondrial density, so the density of mitochondria within a volume of fiber, linearly increases with the amount of volume of training you do. In this study, they looked at training volume as a breakdown of hours, number of sessions, and also the intensity of that session. That was their arbitrary unit of volume. And you can see here, initially it goes up linearly, and then you hit some kind of plateau. Look at this graph and you see all the individual points. These are individual studies, so these are not a very high amount of studies. So it's not a very super valid way of looking at this, because it's very difficult to measure the amount of mitochondria with such a detailed microscope. It's expensive and not easy to do. Another way of doing this, and it's actually a similar readout, is measuring the activity of certain enzymes within the mitochondria. For example, citrate synthase. It's a readout of how many mitochondria there are, right? The number of mitochondria. And here the data is, I think, much more clean. There is on the x-axis training volume, like the same measured as before, and on the y-axis is the activity of this CS or citrate synthase. And you can beautifully see that the more volume you do, the more CS activity there is. So this increases, let's say, the amount of mitochondria per muscle volume. And that's something that makes sense, right? Like the more you train, the more aerobic energy production you need, and the better the muscle will be equipped with that. Important point here on the left side top, if you're a detailed viewer, there's different types of training. MICT, HIIT, SIT, and mixed training. MICT training is low intensity, high volume training, and then obviously HIIT is high intensity training, and SIT is sprint interval training, so really sprinting training. And you can see here, there's no real difference between those training modalities. So that's an important point. So it could be that you just do a lot of high intensity interval training, but really also a lot of volume. This also increases your mitochondrial density. Important point here. Then that's one part of the equation, volume. But you also have intensity. What is the effect of intensity without taking into account the volume of training? And here we have to look at mitochondrial respiration. So that's something else than the density. It is how efficient mitochondria use the amount of oxygen they get to produce ATP. Obviously, the more efficient a mitochondrion becomes, the less oxygen they need for the same amount of ATP. That's also a very important adaptation, right? Like if the muscle becomes more efficient with the oxygen it gets, it probably will also perform better. And that is what this part of the study looked at. It is the effect of intensity on mitochondrial respiration. And here you see a forest plot of all different studies. And on the bottom side, these are all studies that have low intensity. And you can see immediately that there's no real effect on the mitochondrial respiration. So if you do low intensity exercise, maybe the amount of mitochondria improve, but not how well or how efficient they work with oxygen. If you go up and you do high intensity interval training or even sprint interval training, even better, then the mitochondrial respiration actually improves. So this is emphasized by another graph where they looked at intensity on the x-axis, and the y-axis is this CS activity. Remember, CS activity is a readout on how many mitochondria there are within a muscle fiber or volume of muscle fiber, and here there's no relationship. So you can train as intense as you want, your amount of mitochondria will not increase. Good. So to sum it all up, if you want to have more mitochondria, you will need to do a lot of high volume training, so a lot of hours of work. If you want them to work efficiently, so to increase your mitochondrial respiration, the breathing of the mitochondria, you will have to train at high intensity, more CrossFit style workouts. So this brings us to the end question. I have been thinking about this a lot. Does CrossFit or do CrossFit athletes need zone 2? And the obvious answer is, well, it depends. And it mostly depends on, I would say, your level. If you're a beginner athlete, you just started with CrossFit, don't worry about zone 2. Worry about other training foci, for example, movement efficiency, super important, and able to handle high intensity work, so improve your work capacity at high intensity. That is your focus. Don't listen to Huberman or other podcasters who say you need absolutely zone 2 to improve your performance. In CrossFit, it's not the case. Then something else happens if you become more advanced. If you're, for example, an RX athlete, for example, an athlete who can qualify him or herself for the quarterfinals in the CrossFit Opens, then I would say 10, maybe 20% of your training volume could be in zone 2. Why? Let's say as an RX athlete, you train 5 to 7 hours a week. Most of that work is at high intensity, metcons and threshold training. This is probably not enough overall volume to increase the amount or the number of mitochondria per muscle fiber or per volume of muscle fiber. It's better to maybe add 1 or 2 hours at very low intensity to get to that overall training volume to improve those parameters. And that's why I said you need a certain amount, 10 to 20% of your total training volume should be zone 2 just to add up and to get to a higher total training volume, which is probably not possible if you always train at super high intensity because you get overtrained and just overstimulated. Zone 2, around 20% of your training volume, would be easy, long training sessions. Many people don't do that, also when they are advanced. And obviously, again, I always hammer this, try to improve your movement efficiency. Move well, the rest comes later. Then obviously it depends a little bit. If you have a lot of weaknesses, you have to also focus on specific weaknesses, but we're just talking about aerobic metabolism, and then yes, zone 2 could help. Then we can also look at elites, right? Like the real elite athlete, let's say the games athletes, yes, but also maybe sub-games athlete who just made it to the semifinals or want to get their foot into the games. There, the answer is not very straightforward. You have to look at it from an individual point of view. And I think a first assessment you have to do with an elite athlete would be to understand if they're delivery limited or utilization limited. And how you do that, I made a video about this. You can watch it right here, where you can define the limitation of an athlete. And some athletes most athletes in the CrossFit space would be delivery limited. So the limitation of their maximal oxygen uptake or their aerobic capacity, their fitness, would be how much oxygen the heart and also the red blood cells can deliver to the muscles. And obviously, then those people would be better off of doing some zone 2 training, because obviously that will also improve that high amount of aerobic training, will also improve the heart capacity and also the red blood cell production. Those athletes could also do 10, maybe 15% of their training volume, which is already very high, right? So this 10%, you think it's not so much, okay, maybe not. But if you train, let's say 50 hours per week, that's a lot, but also with mobility and stretching and so on, 5 hours of that would then be zone 2, which is obviously quite a lot. And then combined with longer intervals to really attack this delivery limitation. I'm talking about aerobic capacity. Then you also have some elite athletes, not so many, but you will have, that are more utilization limited. And those athletes can deliver sufficient amount of oxygen, but they cannot really use it, right? They cannot really use that oxygen to produce power, so their mitochondrial respiration would maybe be limited. And those athletes don't have to do an excessive amount of zone 2 training. I think they can focus on other parts of their training better instead of only doing zone 2. So again, it depends on the individual. But what they would do, or what would help them, would be this SIT training, so this sprint interval training, because as we just saw, this improves their mitochondrial respiration, so the utilization of oxygen and the generation of ATP in that way. Very important also in CrossFit to have these high power style workouts. Good, so that's an overview. Depends a little bit on which individual athlete and which level you have. Depending on that, you should do zone 2 training or not. So just quickly, just take the example of me. I would be an RX athlete who would be delivery limited, so I would definitely have to incorporate some zone 2 training into my schedule. That would definitely help me also to break through plateaus. Then some of you are here from the Hyrox world, and Hyrox is a bit more straightforward. I would think also the programming is more straightforward. Most to nearly all Hyrox athletes should incorporate some zone 2 easy training into their schedule because it's such an extremely aerobically based sport, and there you really have to maximize the amount of mitochondria you have to improve this overall capacity to work at high intensities under aerobic conditions. Hyrox, I would suggest doing zone 2, again 20 to maybe even 30% of your overall training volume. Good. That was already it for today. I know it was a long one. If you stuck until the end, I hope you got a lot of value out of this video. If you do, don't forget to like and also subscribe to the channel. Really appreciate it. That was it for me. If you want to learn more on the differences between CrossFit specifically and Hyrox and how you have to attack training for both sport or both training modalities, just have a look at this video.